first, these are voltage and current. We've talked about power for heat and energy. Power is also, of course, in electricity. The other important concept is resistance. And just to give you an idea of what voltage is and what current is, if you imagine a river, then how deep is the water? The depth of the water is similar to voltage. So if it's deeper water, it's like higher voltage. And current is how fast is the water moving. So if the water is moving quickly, that's like high current. If it's deep, that's like high voltage. So the power is how much water is moving per second, is the amount of power. So you could have a very deep river that's moving quite slowly, or a very shallow river that's moving very quickly, and they would both be the same amount of power. Electricity is not water, but this is a good way of thinking about electricity to try and get an idea of what these things mean. And to put it into an equation, P equals VI. The power is the voltage times the current. So watts is volts times amps. So Ohm's law says that the voltage is proportional to the current. So as voltage goes up, you get more current. This is true for light bulbs, for motors, generators, and wire. It's not true for semiconductors. Here's Ohm's law. You can see current on the left. As current goes up, voltage also goes up. So semiconductors are different, and solar cells are semiconductors. So you get a characteristic like this. If you think of it as a solar panel with two wires coming out, if you leave the wires unconnected, then no current is going through because it's not connected. And that's zero current. That's called the open circuit voltage, and there'll be a high voltage across the solar cell if it's sitting in the sun producing electricity. On the other hand, if you short circuit, if you connect the two wires together, there'll be no voltage across the solar cell, but there'll be a very high current going through the wire. And in this case, you get what's called a short circuit current. So at zero voltage, you get the very high current, and at zero current, you get very high voltage. So it's kind of the opposite of Ohm's law. And if you're thinking about power, then power is voltage times current. So there's a point somewhere on here where you get the highest power. And you can see the maximum power point, or MPP, is the maximum power that you can get out of your solar panels. The trick with solar panels is to try and keep the voltage and current at the right levels so that you get that maximum sweet spot where it's the highest area under here and the highest power. So this changes, of course. So for example, as the amount of sunshine falls, the shape of the graph changes. The voltage doesn't drop so much. So the voltage is more or less the same, whether it's getting lots of sunshine on your solar cells or not very much, but the current will drop. Another thing that happens with temperature, as the temperature gets higher, your solar cells become less efficient. So the current is not dropping very much in this case, but the voltage is dropping. So this is what happens in a solar cell. And in fact, we don't just have solar cells, we have solar cells and modules and arrays. So each solar cell is put together along with several other cells. The cells are put together into maybe a panel or a module, and the panels are put together into an array. So let's just think about these. We've got the cells in modules, the modules in arrays, and what happens in an array. So we may have something like this, where we have 16 solar panels put together into an array. Well, it's just 12 rather. 12 solar panels put together into a solar array on our roof. So if we think about these 3 panels put together, will they have the same current or the same voltage? There's just one wire, so the wire is going to have the same current going through all the time, and we can add up the voltages of these 3 panels. Will make the voltage higher. How about in this case? In this case, we've got panels in parallel. In this case, the voltage is going to be the same, and we can add up the currents. The currents will all add together. So what happens if one of our panels is blocked out and not working? This may be maybe there's some dirt on one of the panels, or maybe there's a tree shading just one corner of our array and just shading one of the panels. Or maybe there's some snow, maybe a bit of snow is left over in the corner of our roof. In this case, this may not be completely, it may not be down to 0, it may be just shaded and a reduced current in one of the places. And what happens then, often inside a solar module where you have many different cells together, you have what's called a bypass diode. So if in normal situation the electricity is going through this way, if you get something blocked, then the whole of that section of cells will stop producing electricity and it will be diverted. But the others can still produce electricity. If not, then stopping one of these, stopping current in one cell, could stop the whole of your panel from working if you don't have these bypass diodes. So this is what's going on within the cells. I have a picture, by the way, and this worries me a little when I see this picture. Just a close-up, we can see that they've put railings around the solar panel for some reason, and the railings are shading the panels, and if we're not careful, this shade may cut off the whole of a panel or the whole of a module. So this is not a terribly good idea. I need to go and tell them about this. The panels are probably on the roof. That's the best place to put solar panels. They go through a connection unit, so they're connected together. Then they go to what's called a power conditioner, which I'll talk about in a moment. They then often there's often just one wire going to your house and to the grid. Sometimes you'll be sending electricity from your house. Sometimes you'll be buying electricity when your panels are not working. And often there are 2 meters. One of them is counting how much electricity you're producing and selling, and the other one how much you're buying. So what does a power conditioner do? Well, one thing that you need to do is convert direct current into alternating current. Most of your appliances in the house are 100 volts AC, and the panel may be producing different voltages, and when it's sunny it's going to be high voltage. When it's less sunny, the voltage may drop, but you need the same in your house. You need to convert it to a fixed AC voltage. The power conditioner also needs to try to keep the panels producing the maximum power. And what it does is often it's what's called dithering. So it will try and fix the current or fix the voltage, and then try and change them a little bit and see if changing it gets more current or more power. If changing it gets more power, it will change. If changing it gives less power, it will stay. And so all the time it's trying to find the sweet spot and trying to find the best optimum power output, and then convert that into AC. Also, in the case of a disaster, because your panels are connected to your house and your house is connected to the grid, there may be a situation where there's a disaster, the power cables go down near your house. And if someone is going to try and fix those cables, if your house is producing electricity and sending it to the grid, that can be very dangerous. So also the power conditioner will switch off, will isolate the panels in the case of an earthquake or some other disaster. So this is the, again, just to remind you, the maximum power point is where the power conditioner needs to try and control the voltage and control the current so that you're keeping this at the maximum size. Next then, orientation is another issue with panels, and there's an optimum. You should point your panels south, more or less south, because that's where the sun will be when it's the hottest and the highest and putting out the most power. And something between 30 and 40 degrees is the optimum angle for the panels. You can see from here that as you go away from south, your efficiency drops. And as you go away from 30 or 40 degrees, also your efficiency drops. Plus or minus 15 degrees doesn't make a big difference. So your house doesn't have to point exactly south. If you can choose between pointing a little bit east or a little bit west, a little bit east is better than a little bit west. The reason for this is that the sun, as the day goes on, it gets hotter. As it gets hotter, the panel efficiency goes down. So it's better in the morning. Generally, the morning is better than the evening. If you can choose between panels on the east or the west, then choose the east first. So you can see there's a slight. It's try and get the panels pointing south, but if they're a few degrees off, it doesn't make a big difference. When you start to get 45 or 90 degrees off, it starts to drop. And the next thing to think about then is line losses. Sorry to give you a few more equations. You remember power is voltage times current. Now, the voltage is going through wire, and the wire has a resistance. Hopefully this is a low resistance, but there's still a resistance there. And because there's a voltage drop across the wire, and you can work this out using Ohm's law again, you end up with I squared, so the square of the current times the resistance of the wire will lead to the power that you lose. This is power loss in the wires. For example, if you've got 0.02 ohms per meter, if your panels are running at 7 amps, if you've got a 200 watt panel running at 7 amps, you're going to lose 1 watt per meter. So every meter of wire, you're losing up to a watt. So if you've got lots of wire in your house between your panels and your power conditioner, or from panel to panel, then more wire means more power is lost. Just by comparison, when they send power over long distances, they use very high voltage. So something like 110 kilovolts or more. That's 110,000 volts. And just to think of the line losses, if you put the voltage 1,000 times higher, if you go from 100 volts to 100 kilovolts, that's 1,000 times more, that means the current is 1,000 times less. And because the line losses are I squared, that means 1,000,000 times less is your line loss. So just to put this into context, 1 meter in your house is the same as 1,000 kilometers on the grid. So line losses can be quite important. And if you're trying to get your electricity from your house, maybe the house next door, as you send your electricity away, the line losses become more and more and more. So what do you need to think about then? What you need to think about for solar panels is think about the orientation, the angles of the panels. Aim for south facing and about 30 or 40 degrees, but going 15 degrees away from that is not going to make a huge difference. Equal voltages and currents for the power conditioner. So you need to look at the balance of your panels. When you're putting an array of panels together, you need to try and think about the current and the voltage of the panels that will be in series or in parallel as they go into the power conditioner. If you have a tree next to your solar panels blocking the sun, that's not going to work very well. And the length of the cables makes a difference. Here are some examples of some solar panels, and with what we now know, these look quite amusing. Why would you have solar panels in the shade? It's a good idea to get more solar panels, but that house at the top right, it looks like the angle of the roof was pretty good to start with. So changing the angle of the panels, I'm not sure why they would do that. They may be able to get more panels on. Often people try to add as many panels as possible. Often when panels are added to a house, people drill holes in the roof, and it looks like that example on the bottom left. Somebody has made a hole in the roof when they put the panels on. Whoops. And the next one, again, though, some of those panels will be in the shade, and later in the day or early in the day, the other ones will be in the shade. So that may not be the best place to put your solar panels. So think about what to do. Very briefly, so we've talked about solar electricity. It's also possible to generate heat from the sun and to make hot water from the sun. Just very briefly, there are 3 different ways to organize your solar thermal panels. One of them is a flat plate. So this is just a flat collector with water behind it. You can also have vacuum tubes, a glass tube with another tube inside, water going through. Another system is called drain back, where in the morning you send your water into the solar panels. When it gets hot, the water comes back into your house. There are challenges with solar thermal. One problem is overheating, and one problem is freezing. When water gets very hot, it turns to steam, and if you're not careful, this could explode and break your system. And when water gets cold, it turns to ice, and ice also gets bigger and can also break your system. So you need to think about freezing and overheating. In a country where it doesn't freeze, freezing is not a problem. In most places, overheating may be a problem. Hygiene may be a problem if you have water, warm water standing around for any time. You can attract diseases and bugs. You need to think about that. And again, unreliability, it's not always sunny. So if you are using solar water heating, you need to either have a very big system and store hot water, or you need some backup in case the hot water is not coming from the sun. Another idea which I'm going to mention but don't really have time to talk about is what's called PVT, or photovoltaic thermal hybrid. And it's possible in the same panel to have electricity generation and water flowing through the panel. And what this does is it takes heat out, so you get heat as well as electricity. And because the water is taking heat off the photovoltaics, it makes the photovoltaics more efficient, because as they get hotter, they get less efficient. So you can get a very efficient in terms of total energy. These systems can be very efficient, but there's only time to mention them here. Before we go on to the conclusion, and I'm just going to start with some predictions. My first prediction is that the sun will shine. The sun is not going to stop shining, but it will not shine at night time, and it will shine less in the winter. So one thing that is very predictable is the sun and where it will be. You can work out the angles. You can work out the angles at the time of year. That's all very, very predictable. However, we can't predict the weather. We know, I think global warming is happening, and the temperatures will get hotter. As temperature gets hotter, we lose a bit of efficiency from the panels. And also, it may get more cloudy. As the world gets hotter, the oceans will get hotter, and as water gets hot, it evaporates. So we're going to have more moisture in the atmosphere. So this may mean we have more cloudy days, which is not good news for solar panels. The panels, on the other hand, I predict that panels will get cheaper. Their embodied carbon will get less, so they'll become more friendly to the environment as they are made. They'll probably become lighter, which may make things easier to install them. They may become more flexible, both physically, so you may be able to bend panels, and also where you can put panels. So right now, the roof is the best place to put panels. It may be easier to put them on walls or on other places, windows, for example. Also, they will get more efficient. Efficiency will always be less than 100%. And the efficiency is going up slowly. So don't expect to have 90% solar panels, 90% efficient solar panels. You know how much energy is coming from the sun. So there's a maximum amount of energy you can get from your roof. However, most roofs produce enough energy for your house. So you should be able to get all the energy you need from solar panels on your roof. So just a couple of suggestions for your building. One of them is to electrify everything. So if you can use electricity, then electricity may be a very good thing to use for the future. As we get solar panels, as we get more renewable energy, that's going to be electricity. So if you can make a house that can use electricity, then it will be able to use solar power or wind power or nuclear power or whatever kind of power we use. And if you can put solar panels on your roof when you're building, that's a good idea. It's more important to put insulation in when you're building. It's very easy to add panels on the roof later. It's very difficult to add another 10 centimeters of insulation in your walls after you've built them. So when you're building, first priority is insulation. Add the panels if you can, but do think about adding solar panels later. So if you're building your roof, if some of the roof is facing south, that's good for solar panels. If you want to build an east-west facing roof, that's not going to be very good for solar panels. A north-south facing roof is much better for solar panels if you put them on later. And so think about the orientation, think about the angle of the panels, think about the balance of your array, and think about line losses. Here are some references. And that's all. Thank you. Bye bye. Going back into the sun.